Children, now what we need to do is we'll see one more sum. Now in the previous sum is what we have seen, angle of elevation. This sum is what will take angle of depression, so we'll get a clear idea how the sums of elevation and depression are going to be. So what is this particular sum trying to say? It says, from the top of the lighthouse, an observer looks at a ship and finds the angle of depression to be 30 degree. Observer from the top of the lighthouse happens to look at the ship and the angle of depression happens to be 30 degree. If the height of the lighthouse is 120 meter, this time height is known to us of the lighthouse is 120 meter, find how far is the ship from the lighthouse. As stated in my previous sum, that the entire solution mainly depends upon the diagram. If we have the right correct diagram, I think so we are partly done with the sum. So let's start drawing the diagram. What it says, let again AB represent the height of the lighthouse. Let AB represent the height of the lighthouse. Now children, this time it is not angle of elevation, mind you, this time it's angle of depression, so one has to be very careful. I want everybody to refresh your concept. What we did earlier, before starting the word problems, I have given you one slide, which is basic concepts of heights and distances, whereby which I have mentioned that come what may, angle of elevation or angle of depression is always taken with respect to horizontal line. Once again, angle of elevation or angle of depression is always taken in context to with respect to horizontal line. So be very careful when we take angle of depression ka sum. We have to be very, very careful. Once again, the height of the lighthouse is known to us. So let us say that AB represents the height of the lighthouse, 120 meter. The observer is sitting on the top of the lighthouse. So one can say the observer is over here. He sees the ship with an angle of depression of 30 degree. Children, mind you. So I say that let he see a ship over here. So one can say let C be the position of the ship. Let C be the position of the ship. Observer sees the ship with an angle of depression of 30 degree. There may be many students right now telling in their mind that sir is going to plot this as 30 degree. Children, this isn't 30 degree. There are many minds who might be saying that 30 degree should be this. No, it isn't 30 degree. So this is what it is. He observes from B. So this is going to be my line of vision. Angle of elevation or depression is always in context to horizontal line. In the previous sum, the base itself was acting as a horizontal line, mind you. The base itself was acting as a horizontal line, and that's the reason the angle of elevation was straightforwardly given to you as 45. But over here, we have to create a horizontal line, and the angle of depression is this. Children, be very careful in case of depression, angle of depression sum. So it is this angle which is given to me as 30. Angle of depression is with respect to horizontal line. This is what our horizontal line is. It is given to me as 30. I intend to find out what the sum demands. How far is the ship from the lighthouse? We need to find out this distance. We need to find out AC. Moreover, we can say that lighthouse is also perpendicular to the surface of the sea or ocean, wherever it is. So only thing which one has to keep in mind is during the word problems based on angle of depression, it is not going to be this angle. Angle is always in context to horizontal line, which is this. This is what our line of vision is. So if this is 30, children, don't you think so that both these lines, though this is a hypothetical imaginary, but this line and this line are parallel to each other, mind you. So if this is 30, this is also 30 by alternate angle theorem, right? If this is 30, this is also 30. So we ultimately have to focus ourselves in triangle BAC. We have to focus ourselves in triangle BAC. But why this thing was drawn? Actually, conceptually, it is this angle of depression which is equal to this angle by alternate angle theorem. Let's start. As I said in my previous sum, we always need to write down some kind of statements, is what we are going to briefly jot down what exactly the statements could be. On similar lines is what I'm going to write down. Solution. Let AB represent the height, again shortcut, height of lighthouse. This time the height is given to us. So I shall immediately write down AB is equals to 120 meter. Equation number 1. Let C be the position of the ship. Let C be the position of the ship. Let AC be the distance of ship from the lighthouse. Let AC represent the distance between the ship and the lighthouse. Angle of depression. Angle of depression, which over here will be count for, if I have to give this as M. Angle of depression is measure angle MBC, which is equals to measure angle BCA, which is 30 degree. Once we are done with everything, after writing down all the statements, we immediately need to go into the figure, always. And again, I'm going to ask the same question. What is being given to us? In context to this angle, opposite is given to us. Adjacent is what I need to find out. So what I'll make use of? I shall make use of tan. Absolutely. So in triangle BAC, tan 30 is again opposite AB by AC. Mind you, this is the definition of tan 30. It's opposite upon adjacent. Tan 30 value is 1 by root 3. We should know all the values, children. We should know the standard values. So far as the standard values are given to us, we should know. In some of the boards, non-standard values are being given. Then we have a logbook from where we can refer the answers for. Tan 30, 1 by root 3. AB is known to me, 120. AC is what we need to find out. Just write down besides it, since tan 30 is 1 by root 3. Moreover, you can write down also from 1. In the previous one I had written down, since AB is 120, I can say from 1 also, which is 120. On cross multiplying, what do we get is AC is equals to 120 into root 3. Children, we are taking root 3 ka value as 1.732. In some of the books, you'll be given the value as 1.73. We are making use of 1.732. So AC is 120 into 1.732. If your teacher says, if your board says that the value should be taken as 1.73, you can restrict your calculation to 1.73, whereby which I have taken 120 into 1.732. On solving, on multiplying, you will get answer as 207.84. 207.84 meter. So I can say the distance, or rather ship, is at a distance of 207.84 meter. Final answer is what you have to write down, children, in words. So the distance in their language, find how far is the ship. The ship is at a distance of 207.84 meter. Children, only one thing is what I would like to add further. If your sum says that write down the final answer to the nearest integer, nearest whole number, nearest natural number, nearest integer is more often all the boards ask you, then we cannot write down 207.84. We have to round it off. Nearest integer will be 208 meter. 208 meter. One more question can be added. Find out the answer to the nearest correct one decimal place. So if they happen to ask you correct up to one decimal place, I shall always focus on my second decimal. If the second decimal is 5 or more than 5, I shall increment the previous one by 1. But over here, it's not the case. So if I would like to write down correct up to one decimal, my answer would have been 207.8 meters. So children, here in the final answer is what many board will be asking you these as your punchline questions, writing down the final answer to the nearest whole number, nearest integer, correct up to one decimal places, significant digits. Depending upon various boards, they can ask you this in your question. So I hope you have understood how to solve these kind of sums, and mainly the angle of depression.